All right, so in this video, I'm going to explain this problem faced by the management of Madeira Computing Company, who is considering the introduction of a wearable electronic device with the functionality of a laptop computer and phone. So, of course, in this model, there are a bunch of deterministic inputs and a bunch of random inputs. So the first deterministic input that we have is the fixed cost. So the fixed cost to launch for this new product is known by now, and which is $300,000. So that's what I have right here, which is just the number 300,000. And then we also have that they are going to sell the product for $300 per unit. That is also not a random variable. They have decided that, and again, that is my deterministic input right here, the unit selling price. Now, the two random inputs that I have in our model are the variable costs and the demand. So the variable cost for the product is expected to be between $160 to $240 per unit, with the most likely value of $200 per unit. Okay, so again, we don't know exactly what it is, but we know that it's gonna be between these two values, with the most likely value of $200 per unit. And the demand for product is expected to range from 0 to 20,000 units, with a most likely value of 4,000 units. So the first part of the problem is to develop a what-if analysis based on the base case, worst case, and best case. So the base case essentially is we are going to take into account what is most likely to happen. And so we already have the deterministic inputs, and for the random inputs, we are just going to plug in what's most likely to happen and see what is that profit is. And that's going to be my base case profit. Okay, so for example, for the variable cost, the most likely value is $200 per unit. So that's what I'm going to put in here, 200. And for demand, I have the most likely value of demand is 4,000. So that's what I'm gonna put in right here, 4,000, right? And because I already give you the formula in the model in your Excel sheet, so you already have the profit calculation right here. So your profit is going to be, for the base case, the profit is going to be 100,000. Now coming to the worst case. So the worst case, again, we are just going to change the random inputs because the deterministic inputs are for sure. So for the variable cost, the worst case variable cost is going to be $240 per unit, right? Because it can range from 160 to 240. So the worst variable cost is going to be 240. So that's what I'm going to put here. And then for demand, the worst demand is going to be 0. Right? So the worst case that can happen is I don't have any demand for the product. So I'm just going to put 0 right here. And that gives us the worst case profit to be, of course, it's a loss, is negative $300,000. Okay. Finally, the best case. So the best case variable cost is $160 because that's the lowest. Right? So I'm going to write 160 here. And then for demand, the best case demand is going to be 20,000 units because that's the most demand that we can have. And I'm just going to put in 20,000 here. Okay, so that gives us this profit, and that's what I'm going to put as my best case profit. Right here, so 2. So that's basically part A. Now coming to part B, now we are going to use simulation to get a better perspective of what could happen in terms of your profit, right? So what we're going to do is we are going to assume now this, again, the deterministic inputs are going to be the same. What's going to change is your random input, right? So each of your random input is now going to take a random value. So we are going to generate that random value using a distribution. So what the marketing team has decided that they think that they want to model the variable cost as a uniform random variable with a minimum of 160 and maximum of 240. So now if we look at your cheat sheet, to generate a uniform random variable or a continuous uniform random variable. This is continuous because the cost could be like 165.5, right? It doesn't need to be a whole number, so it could be some cents. So that's why we are going to use the continuous uniform distribution here. And the formula for that would be using your lower bound plus the difference between your upper and your lower bound, and you're going to multiply that by rand to generate the random number between 0 and 1. So as long as you get a value between 160 and 240, that means that you did it correctly. The second random parameter is the demand. And they think that the product demand is 1,000 times the value of a gamma random variable with an alpha parameter 3 and beta parameter 2. Okay, so this is also how you generate a gamma random variable. And again, I think you had it in your cheat sheet too. So you're gonna, but just remember that you have to do demand equals to 1,000 times this gamma. So that's what I'm gonna do right here. 1,000 times. Then the formula to generate a gamma random variable is gamma inf, just like norm inf. Then the probability is of course going to be random. And then my alpha is 3 and my beta is 2. And there you go. So that's your demand. And in this instant, your profit is negative. Okay, so once we have everything, we are going to do our simulation trials. And each of the trials, we're going to see what's going to be my unit variable cost, demand, and profit. So these three are only my random inputs and outputs in the model, right? So these two are random inputs, and this is the random output. So we're going to start with writing 1 to 1,000. To do that, first you write 1 here, and then you go to home and fill, and then series, you're going to write columns, and your start value is going to be 1,000. Next thing is to just link everything correctly, right? So you're going to link to unit variable cost right here. Demand right here. And then your profit, which is going to be right here. Once you did that, you are going to select everything. Control Shift down arrow or Command Shift down arrow. And then you're going to go to data and what if analysis and then data table. In data table, you're going to keep your row input cell empty and your column input cell should be any cell that is not occupied or not in the table. All right. So once you do that, you should have all the what if analysis. And just to be consistent, I'm going to make all the profit as a currency. There you go. All right. So now once we have everything, now we are going to create some statistics. So for profit statistics, I already gave you the formulas right here, the count, min, and max. So next one is the average. So you're going to use the average formula, that one. And your output range is going to be profit in every case because you are looking at the profit and how that changes. That's your average profit. That's a pretty good profit, I would say. And then the standard deviation will be, again, the standard deviation at S. And then you're going to Control Shift down arrow. All right. Finally, they are also interested in the probability that the project will result in a loss, right? So what is the probability that the project will result in a loss? So I want to say this should be less than 0 because that will be a loss, right? Otherwise, if it's profit equals to 0, that means we're breaking even. So to calculate the probability, again, you're going to use the COUNTIF function. And then you're going to do your range, comma, your criteria is going to be less than 0. And you're going to divide everything up by 1,000, which is the number of times you're doing the trial. So you have a 0.2 probability or a 20% chance that this project will end up in a loss. And I would say that's not a very small number, right? We are also going to look at the 95% confidence interval for the mean profit. which means that how confident are you in your average profit, right? So to do that, I'm going to do average minus. So it has an upper bound and a lower bound, and I'm going to start with the lower bound. Confidence to t. Your alpha is going to be 0.05. Your standard deviation is going to be right here. And the size of your sample is 1000. And then the upper bound is going to be again average, but in this time this will be a plus instead of a minus. And then again confidence t, and then alpha is going to be 0.05, and then against the standard deviation and the size. Okay, so you are 95% confident that your average profit will be between $297,000 to $345,000, right? So that's a pretty good number, I would say. Now let's look at the bin and frequency. So bin, for bin, again, you're going to start from your minimum. And I give you a suggested bin width to be 150,000. Feel free to do any other way, whatever you think is better. Wait, actually, I'm sorry, this number should be, that's suspicious. Minimum of profit. Okay, so let's do this. This is a minimum of profit and max of profit. Okay. So now you're going to start with your bin with the minimum profit. And I suggested your bin width to be 150,000. So the last bin plus 150,000. And you are going to drag it down until you have passed the maximum. So I have not passed it yet. So I'm going to just drag it down a little bit more. And maybe I'm going to just to be safe, I'm going to drag it down too. Yeah, that seems to be good. Then my frequency. So I would say just drag it down a little bit more than your maxes, because as you know, these numbers are changing, right? Because every time Excel is generating a random number, all these values are changing. So just make sure to drag it a little bit more. So your frequency is going to be your frequency function. Then you're going to take your data array, comma, your bins array. And these are your frequencies. And finally, let's get the histogram. So for histogram, just get all of your frequencies and then insert a chart. So this is your profit. And you also need to change your horizontal axis. So I'm gonna do select data and then edit and select your bin and press OK. OK. And there you go. So now this is the histogram for the profit. And I want you to look at it and think about Part C on what is your recommendation regarding where to launch the product. So you can see on one hand, it can create a loss like a negative $100,000. And that does have quite a bit of probability. But on the other hand, it can also give you a profit of 1.8 million. And the highest probability is to give you a profit of $175,000. So depending on what kind of person you are, if you are really a risk averse person, you probably would not launch the product because you don't want to have like a negative $100,000 profit or a $100,000 loss. But if you're a risk lover, you would probably go for it just because you can have like a almost 2 million profit, right? So it depends on what perspective you take, and I would expect that you write this portion of the answers accordingly.